Hello dear students, I hope you are doing good, doing well. Today we will discuss about a very important topic in context of J and NEET. This is rolling motion in inclined plane. Very important topic. First of all, you need to memorize what is rolling motion. In case of rolling motion, we have an object like this. It can be a ring, sphere, solid sphere, hollow sphere, cylinder, like. At this bottom point, the relative velocity at this point should be zero. Relative velocity at this point should be zero, and relative acceleration should also be zero. And one more thing, this surface should be rough. Should be rough. Means velocity at this point, let's say P point with respect to ground is equal to zero. Acceleration at this P point with respect to ground is zero. And should be rough surface means it is offering some frictional force F is equal to mu into r. These are the condition for rolling motions, right? So now start the topic. Rolling motion over an inclined plane. So we have an scenario like this. Here an object is placing at this position. It can be ring, it can be solid sphere, hollow sphere, cylinder. This angle is theta, let's say. This object will roll down and reaching at this point, right? I am taking two cases here. First one, if the surface is smooth. First case, the surface is smooth surface. For smooth surface, we have, suppose this object is placing at here. Now this is mg, this height is h actually, and this is mg cos theta. By geometry, this angle will be theta here, and this component will be mg sin theta. This is vector components actually, right? There is no frictional force, so object will come down like this without rolling. It will slip on this surface. If this object will slip, then there is no opposition of force like this. There is no force here, so we have only this one. So this one force is responsible for slipping. So mg sin theta minus opposition, no force, minus t minus 0 is equal to net force m into a. So we can say m into a is equal to mg sin theta. So m and cancel out, a is equal to, it is g sin theta. This is the acceleration while slipping. When there is no frictional force is there, no rolling, then this is the value of acceleration while slipping, right? Velocity will remain same. Velocity at this point we can calculate v square minus u square is equal to 2as. V square minus u square is equal to 2as, where s is this distance. This is actually s. So v square is equal to, u is 0 actually. We are starting from here, then u is 0. We can say 2as. V square is equal to 2 as it is. A is actually g sin theta and s is s. So v square is equal to 2g sin theta. We can put the value of s. This is actually hypotenuse. So sin theta is equal to, perpendicular is h, hypotenuse is s is equal to h upon sin theta. So v square is equal to 2g sin theta into h upon sin theta. Cancel out, v square is equal to 2gh, and this is actually root 2gh. This is the result as of vertical motion. Vertical motion में भी same result आता था. This is the same result exactly with the vertical motion. This is the height h, right? So come at the main topic, which is rolling motion. This is the case of slipping only, right? I hope this is very interesting for you. Now come at the main topic, which is the rolling. So this one. Before the starting the topic, I want to tell you some formula we have for moment of inertia. For ring 1 by only mr square, where m is mass, r is radius of the ring. Disk, it is half of mr square. This is only about center of mass. This moment of inertia is only about center of mass. Solid sphere is equal to 2 by 5 mr square. Hollow sphere is equal to 2 by 3 mr square, right? Last one is cylinder, solid cylinder. It is actually half of mr square, like disk. This one. You need to memorize this formula, because in the formula of acceleration and velocity you are getting the term of moment of inertia about center of mass. Then you have to put this formula exactly at here. One more thing, we have to know about the radius of gyration for every object. I am starting from ring here. We know the radius of gyration is it is actually k. So we can say for ring it is mk square is equal to mr square. Yes or no? Clear? So we can say m and I cancel out. K square is equal to r square. K is equal to r. Both are important. Next one, for disk, mk square is equal to 1 by 2 mr square. This term is actually, this moment of inertia is actually m into k square. That's all. Just compare and solve the value of k. M and m cancel out. K square is equal to 1 by 2 r square. Then k is equal to 1 by root 2 into r. Right? For solid sphere, mk square is equal to 2 by 5 mr square. M cancel out. K square is equal to 2 by 5 mr square. So k is equal to root 2 by 5 into r. Sorry, r. This one. You can calculate the solid cylinder also, like disk. You are getting same result for solid cylinder. You need to memorize these formula also for this topic. You can take screenshot also. Now this surface is, this height is h, this angle is theta, and this object is placing at here. You can say it is solid cylinder. You can say solid cylinder, like this marker. It is solid cylinder. It is placing at here, and this is rough surface. I am taking at here to clarify the diagram. So this will rotate like this with alpha angular acceleration. We have v is equal to r omega, a is equal to r alpha, omega is equal to v upon r, alpha is equal to a upon r. You need to memorize this formula also. So this is m into g, this is mg cos theta, this is mg sin theta, right? So this object will roll like this. This is a rough surface. Friction will be responsible for torque. Why it is so? For rolling, if I am applying some force like this, means this force or this line joining will pass through center of the mass. So this object will make only translatory motion. If the line joining will pass through center of mass, then this object will make translatory motion only. If I exert force like this, this force is responsible to make roll. because this force is not actually passing through center of mass. Center of mass is here, but this force is not passing through center of mass. Line joining of this force is not passing through center of mass. So for the rolling, line joining should not pass through center of mass. So frictional force like this, and this is the radius r. So this is small f, and this is radius r. Right. So for FBT for this diagram, we can say mg sine theta. Opposing force is F is equal to m into A. This is net force. Very crucial thing. Very important equation. Now for torque, we know very well torque is equal to I into alpha, right? Torque is equal to F into R, force into perpendicular distance. We will use both of them. Torque is equal to I alpha, and torque also equal to F cross R, या फिर multiplication F dot R. No issue. Not vector sign here, so I am writing just. So torque is equal to F into R. Why I am writing this small f? Because this small f is only responsible to make roll, right? So torque is equal to I into alpha is actually, compare both these equations, we can say F into R is equal to I into alpha. F is equal to I into alpha upon R. You can put the value of alpha. F is equal to I into what is alpha? Alpha is actually A upon R. What is A? A upon R. R and R is actually R square. This is the formula of force. It is frictional force. You can put this value at here. You can use equation number whatever it is 2. Second equation use in first equation. What you are getting? mg sin theta minus F equal to m into A. So F equal to mg sin theta minus ma. Alright. F equal to, what is F? Ia upon R square is equal to mg sin theta minus ma. You can say Ia upon R square plus ma equal to m into g sin theta. Alright. On solving this equation, what are you getting? Take common a and solve further. I think you are getting a is equal to m and cancel out will be there. You are getting g sin theta upon 1 plus I upon mr square. I upon mr square. This value of acceleration you are getting from here. Alright. Now, what is the velocity at this point? Now, what is the velocity at this point? For velocity, we are taking v square minus q square is equal to 2as. कुछ याद आ रहा है? पिछला टॉपिक ऐसे किया था, स्लीपिंग वाला, राइट? And v square is equal to 2as because u is 0. V square equal to 2 into what is a? A is actually g sin theta upon 1 plus I upon mr square. Alright, into s. V square is equal to 2 into g sin theta upon 1 plus I mr square. What is the value of s? S is this distance. It is actually what? Hypotenuse. So sin theta equal to h upon s. S equal to h upon sin theta. Put this one at here. We can say h upon sin theta. This one cancel out. V square is equal to 2g h upon 1 plus I upon mr square. Is clear? Root. This is the value of velocity. Very important for velocity and for acceleration. Alright. Now I am taking for solid cylinder. I can use the value of moment of inertia at here and at here to get the exact value of velocity. You can put also. I am putting the value of value of moment of inertia for solid cylinder. May I erase this one also? I hope you are getting this result. You can solve this equation also. So now A is equal to G sin theta upon 1 plus, what is the value of I for solid cylinder? Half of mr square, 1 by 2 mr square upon mr square, right? Take LCM, G sin theta upon mr square plus half of mr square divided by mr square must cancel out. What are you getting? A is equal to G sin theta plus 1 plus 1 by 2. All right, A is equal to, it is 3 by 2 G sin theta upon 3 by 2. We can say 2 by 3 G sin theta. Value of acceleration. By similar manner, you can calculate the value of velocity also under the root, right? So this value of acceleration also. So you can use this value of acceleration at here to calculate the value of required friction force to make a rolling. Now I am solving the frictional force. Required frictional force. So F equal to mg sin theta minus ma. F equal to mg sin theta minus, what is m? M as it is A. A is what? A is what? Sorry, A for solid cylinder. This one 2 by 3 g sin theta. F equal to, take common, mg sin theta will be common. So we can see also a 3 mg sin theta minus 2 times of mg sin theta divided by 3, right? So F equal to 3 minus 2, 1 mg sin theta only divided by 3. We can say also 1 by 3 mg sin theta. This is the required friction force. इतना तो कम से कम चाहिए हमें. This is the required frictional force value for rolling. All right. So we need to calculate now the value of coefficient of friction here. We need to calculate the value of coefficient of friction. Coefficient of friction. We know very well F equal to mu into R. All right. R is actually this one. This is R, normal reaction. Normal reaction is just opposite to mg cos theta. So we can say here R equal to mg cos theta. So हमें चाहिए ऐसे mu is equal to F upon R. Mu is equal to F. F is this one, 1 by 3 mg sin theta. 1 by 3 mg sin theta. What is R? It is actually mg sin theta, mg cos theta. mg cancel out. Mu is equal to 1 by 3 as it is. Sin by cos it is tan theta. All right. This mu should be static, and this is greater than or equal to 1 by 3 tangent theta. And tangent theta is less than equal to 3 times of required static friction. So by this manner we can say what should be the angle, what should be the coefficient of static friction to make roll. All right, this is the value of friction force, angle and coefficient of friction. Very crucial and very important thing. Sometimes direct formula are asking in NEET exam, this one, actually this one also, for a particular object like ring, like disc, like cylinder, like solid sphere. All right, let's solve some questions behalf on this particular topic. I have some question. So first one, you have to write each and every formula actually first of all on the blackboard. So what is the value of a? A is equal to g sin theta upon 1 plus I upon mr square. If you are don't write the value, if you are not writing the value of I actually, so you can write g sin theta upon 1 plus k square upon r square. So velocity v is equal to 2gh upon 1 plus k square upon r square under the root. This is actually velocity. Alright. Frictional force I have already told you. So first question. We have a second method to calculate the velocity with the help of energy conservation also. This is h, this is object rolls down and reaches at this position. All right, so apply the energy conservation, mechanical energy. So at this position only potential energy it has, at this position only kinetic energy at this or no. So we can say m into g into h बराबर होगा 1/2 mv square plus 1/2 I omega square. It's clear? So you can put the value of omega here. Omega, you can put the value of omega mg into h equal to 1/2 mv square plus 1/2 I, as it is omega is v square upon r square. Omega square is v square upon r square. Actually v is equal to r omega. So omega is equal to v upon r. You can put. Now second one, you can put the value of inertia value for a particular object, right? So by this method you can solve out the value of velocity actually. Is clear? By energy conservation. All right. So I'm taking the question now. First question is, NEET 2014 question. What is the ratio of this one? It is a solid cylinder, solid sphere actually, solid sphere. What actually the ratio of acceleration of sleeping and without sleeping? Solid sphere, what is the ratio of acceleration of sleeping and without sleeping? So for sleeping there should be no rolling. This surface should be smooth, right? For sleeping it is only the acceleration this force is mg sin theta, right? This force is only the responsible. So mg sin theta minus nothing is equal to m into a, cancel out. So g sin theta is equal to a, so we can say a is equal to g sin theta. Is clear? This one. So for rolling we have a equal to this one, g sin theta divided by 1 plus I upon mr square. We have the value of I. A is equal to g sin theta upon 1 plus, what is the value of I for solid sphere? For center of mass it is 2/5 mr square. 2/5 mr square upon mr square can mr square cancel out. A is equal to g sin theta upon 5 plus 2 by 5. So A equal to g sin theta divided by 7 by 5. A is equal to 5 by 7 g sin theta. This is for rolling, this is for sleeping. So AS upon AR equal to रेशो इन्हीं दो का निकालना है. तो g sin theta divided by 5 by 7 g sin theta cancel out. AS upon AR is equal to 7 by 5 only. This one is the ratio. Is clear? Okay. Let's move for second question. You can take screenshot also. Very important topic this is. Very important question is this. So NEET 2013. Remember NEET 2013. मैंने आपके लिए वेलोसिटी का फॉर्मूला निकालने के छोड़ा था एनर्जी कंजर्वेशन से. वो मैंने इसलिए छोड़ा क्योंकि अभी एक क्वेश्चन के अंदर वो कवर हो जाएगा. Now we have a height equal to 3v square upon 4g is given, right? ये हाइट है. ऑब्जेक्ट का नाम बताना है. क्या होगा ऑब्जेक्ट का नाम बताना है. रिंग है या डिस्क है या फिर सॉलिड स्फीयर है, सॉलिड सिलेंडर है. इट्स क्लियर. आपको ऑब्जेक्ट का नाम बताना है. सो व्हाट कैन यू डू. ये ऑब्जेक्ट यहां से चला है, यहाँ पर रस्ट के ऊपर होगा, टॉप मोस्ट हाइट है ये. तो ओनली पोटेंशियल एनर्जी इट हैज एट दिस पोजीशन. यहाँ पर दोनों एनर्जी होंगी. दोनों एनर्जी मीन्स रोटेशनल काइनेटिक एनर्जी प्लस ट्रांसलेशनल काइनेटिक एनर्जी. सो वी कैन से फर्स्ट ऑफ ऑल व्हाट इज रोटेशनल काइनेटिक एनर्जी. 1/2 I omega square. Remember m replaced by I, v replaced by omega, A replaced by alpha, F replaced by torque, P replaced by angular momentum. These are the scenario. We have 1/2 mv square, so it is replaced by 1/2 m replaced by I and v replaced by omega, so omega square. That's why. By the way, we have particular relation or derivation for this, but I told you the method to memorize the formula. Okay, so 1/2 mv square translational kinetic energy plus rotational kinetic energy I omega square. दोनों होंगे. यहाँ पर घूमते हुए आएगा ऑब्जेक्ट और चलते हुए आएगा, राइट. तो इस एट दिस पोजीशन देयर इज नो हाइट, सो दिस इज नो हाइट ऑन लेफ्ट साइड. सो at this position there is no velocity, only potential energy it has. So potential energy is m into g into h. You can put the value of h from there. 1/2 mv square plus 1/2 I omega square is equal to m into g into h. H is what? 3v square upon 4 into g. You can put the value of omega square. Omega square is actually v square upon r square. Okay. Now we have to find the value of I. So take this term on left side only. I v square upon r square is equal to m into g v square up 3v square upon 4g. All right. Minus 1/2 m v square. G and g cancel out. So 1/2 I v square upon r square equal to this one we can say 3m v square upon 4 minus 1/2 m v square. So now this is same half of I v square upon r square. Take LCM, 4 v LCM, 3m v square minus 2m v square. So 1/2 I v square upon r square we can say only mv square upon 4. V square cancel out. 2 2 are 4. Clear? I upon r square upon m by 2. I is equal to m r square upon 2. 1 by 2 mr square. This is the moment of inertia about center of mass. ऑप्शन में रिंग, डिस्क, सॉलिड स्फीयर, सॉलिड सिलेंडर. रिंग के केस में ये होता है. इट्स क्लियर? सो बाय दिस मैनर यू कैन कैलकुलेट दिस टाइप ऑफ क्वेश्चन. इसलिए मैंने आपके लिए वो वेलोसिटी का कॉन्सेप्ट छोड़ा था कि आप खुद ट्राई कर लें. इट्स क्लियर? लेट्स मूव फर्दर फॉर लास्ट क्वेश्चन ऑफ दिस टॉपिक. राइट, एक सॉलिड सिलेंडर है. May I erase this thing? You can take screenshot also. I have a solid cylinder, solid sphere actually. रेशियो निकालना है रोटेशनल काइनेटिक एनर्जी टू टोटल काइनेटिक एनर्जी. रोटेशनल काइनेटिक एनर्जी upon total kinetic energy. This is the question for solid cylinder. All right, so we have rotational kinetic energy. First of all, we will find this one. Rotational kinetic energy is actually 1 by 2 I omega square. It's clear? So rotational kinetic energy is equal to 1 by 2 I as it is. What is omega square? Omega is what? V square upon r square. It's clear? What is inertia for this one? For rotational kinetic energy, what is the inertia for sphere? Solid sphere, I think it is 2 by 5 mr square. Alright, I think it is 2 by 5 mr square. But no need to put here 1 by 2 I as it is. Sorry, I is m into r square. 2 by 5 mr square. 2 by 5 mr square into my v square upon r square. R square cancel out. Rotational kinetic energy equal to 2 to cancel out. 1 by 5 m as it is v square. This is rotational kinetic energy. Now ये तो निकल चुका, टोटल निकालना है. टोटल काइनेटिक एनर्जी इक्वल टू ट्रांसलेशनल काइनेटिक एनर्जी प्लस टोटल एनर्जी kinetic energy. So translational kinetic energy plus rotational kinetic energy. We have rotational only here, translational is not there. Total kinetic energy is equal to translational kinetic energy is only 1 by 10 square plus 1 by 5 mv square. So take LCM 10, 5 mv square plus 2 mv square. It is actually 7 mv square by 10. This is total kinetic energy. And rotational energy is this one. So rotational kinetic energy upon total kinetic energy is equal to rotational 1 by 5 mv square upon what is total 7 by 10 mv square. Cancel out. We can say this one is equal to 1 by 5 into 10 by 7. It is 2 by 7. 2 by 7. Clear? This one. Alright. This is the question. I hope this topic is very helpful for you. आगे वीडियो आती रहेंगी. Thank you so much.